Okay, now we are back from the field after we've gone to collect data, as we did on our third knowledge area in techniques and measurement scales. We looked at different techniques and tools for measuring data: nominal, ordinal, interval and ratio scale. We looked on data collection methods. We looked on questionnaire, in-depth interview, observation, and focus group discussion. So after you've gone to the field and come back with your raw data, what next is processing and analysis of data. You want to get the informed information, the required information of the data. Okay, you can see we have a cartoon here showing that it's recording data. So we move on with data processing. So data processing simply means that when you have the data collected, you want to translate to usable information. You want to make a meaning of what you've collected. So this processing involves manipulation, manual manipulation or electronic data processing, which involves execution of the following operations: editing, coding, classification, and tabulation. First you get your data, then you start to edit. Some areas we correct or we detect some errors. In the area where we're supposed to write F for male, for female, someone wrote F for M, which means male. Or you can have let's say you want to see, you have obtained age data. And in the age you have someone with 1,000 years. That is not possible. So you go and omit those errors. Okay. Or someone has miscollected data. You have some missing information. You go about to know why there is missing data in this area. Another part of data processing is coding. Now you've got your data. You want to code that. You have to give the meaning. For example, from questionnaire, you code your questionnaire that maybe in case of gender, male and female, 1 means male, 2 means female, so that it can be easily analyzed. You classify data into categories and classes. For example, in case of age, when someone is 0 to 10 years, or 12 years is a child, or a boy or a girl, to adolescence, a youth, to mature or old age. You categorize your data in that way. Or from 1 up to from 4, from 4 up to from 6, graduate, postgraduate, undergraduate. That's how we do coding. Okay? And then what follows is classification. So you arrange now, after you've coded, you arrange it to the classification that I have given you, undergraduate. If someone has put, he has 13 years of studies, means that one person has gone up to undergraduate level. You are classifying your data level. Okay? And tabulation. Tabulation means it's a primary. Way of analyzing your data. You put your data in tabular forms, in charts of males and females. You describe your data. Simply it's to describe your data. Okay? Then what you can do now is you summarize your data. You can summarize your data into frequency tables, frequency distribution tables. You can summarize your data into stem and leaf, whereby you give numbers from row and column. The row is a stem, column is a leaf. Or you can do graphical presentation of your data. Graphs helps in using comprehensible. When you have a frequency table, it can be a very comprehensive to read. But when you use graphs or diagrams, it is simple to understand. For example, a histogram, frequency curve, ogive, and bar chart. I hope you are familiar with this from geography or from your undergraduate mathematics. Not undergraduate mathematics, or your ordinary level mathematics. Then we come to the other part of the coin, other side of the coin, other part of our process and analysis of data for knowledge area 4. So we want to know ourselves what is data analysis. Yes. So we've got the data, we've edited the data, we've coded, we've classified and built some tables. Now we want to analyze according to what we want to achieve. So data analysis is the process of systematically applying statistical or logical techniques to describe and illustrate, condense, recap, and evaluate data. Data analysis can be either descriptive or inferential. As a descriptive, I said before, we have tables, figures. That one we can say it's a descriptive analysis of data. Inferential involves in-depth understanding, deep mathematics, analysis of data, relation between variables. We do inferential statistics. So data analysis in research falls under the following measures. We have four major measures of data analysis, but we can say we have other measures. So we can say we have more than 5 measures of data analysis. The first measure is a measure of central tendency. The other one is a measure of dispersion. The other one is a measure of skewness. The other one is a measure of relationship in the other measures. This is start with measure of central tendency. Measure of central tendency, we want to know where our data is located. So we have 3 common measures of central tendency. We have a mean, we have a median, and mode. So here is our mean. Mean is obtained by adding all of the observations we've got and dividing by the sum number of observations. Mean simply means an average. What is an average age of the information that you have collected? What is an average height? Okay? Or you have asked about something. What is an average response of that something? Right? Here's the formula for the ungrouped data. Okay? It is this mark means summation of x means the number of the observations, divided by n means x means the total of the observation, n means the number or some number of observations for ungrouped data. But for the grouped data, here's the formula: summation of f of x and summation of the frequency. Okay. Then we have the median. Median is the middlemost observation in the data. What is the middlemost observation in the data? If we arrange the data in an array, we say we have our heads or our marks from 1 to 100. Well, which one is the middle marks? Yes, middle marks can be 50, is it? 1 to 100. Which is the middle height? What is the middle age of the data that we've collected? Okay, for ungrouped data, you can say that the middle one, as you can see the example, 23, 24, up to 33. If you count this 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle number between 9 number is the 5th number, which is 28, as you can see. But if you look at this another example, what happens when you have 2 middle numbers? You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have 10 observations. How can we calculate a middle number? So we take the middle number, the 2 middle number, which means it is 5 and 6. 1, 2, 3, 4, 5 and 6 divided by 2. As what we've done here. We get our median. But there was also median for grouped data given by this formula, where I is the lower limit of the median class. We will go about this calculation in the last slide. Then we go to the mode. Mode is the value which is the biggest value in an array, the biggermost value on your data that you've collected. Mod is the value which repeats maximum number of times. You can say it that way. Or it is the value which is the biggest among other values. Formula for computing mod, as you can see, it is that way. So if you go back, our mod here is 34. Oh, sorry. If you go back here, our mod is the most repetitive number, which is 26. But if you have no number which is repetitive in itself, we could easily choose 33 because it's the biggest number. Can't consider that. Okay? This is example of grouped data. When you see a table of grouped data, we have calculated the length, maybe a length of our carrots that from a farm. Here is the frequency. How many times they take. The length that this carrot fall between, you can see. From here now you can go about calculating mean, mode, and the median using these formulas. Okay. So let's try to do some calculation here from the board. Start by the median. Let's give it by the data there. Give it in meter. 150, 154, 155, 159, 160, 164, 165, 169, 170, 174, 175, 179, 180, 184, 185, and 189. Okay. Then I want to leave this place here for class values. You understand this in a short while. But here we have also viewpoints. We come to that shortly. And we have our frequencies. F, which are given there. I hope you can see. My handwriting is not that good. Okay. Frequency is given as the following: 5, 2, 6, 8, 9, 11, 6, 3. We start by calculating the mean. And you say mean is the summation of frequencies and midpoint of the summation of frequencies. So you need to add this, the following frequencies. If you add them, you get 50. You need to calculate a midpoint. How do you calculate a midpoint? You add lower plus upper class interval divided by 2. So when you divide by 2, you get 152 here, 177, 157, 162, 172, 177, 182, and I missed a number. So we proceed with our midpoints. 165 plus 169 divided by 2, you get 167, 172, 177, 182, and 187. So here, these are supposed to be midpoints. So I'll shift these values here. I didn't look well there. So I want to shift them here. These are supposed to be midpoints. 162, 167, 172, 177, 182, and 187. Okay? Alright. So I leave this one blank because we will use class boundaries when we want to calculate mode and median. So that's why I left it vacant or purpose. So this midpoint means x. Okay? Now we have all of our x's. When we have okay. Here we said we want a summation of f of x. Means we need to create another column of f of x. Is it? We need to create another column of f of x. Which means midpoint times frequency. So when we multiply midpoint times frequency, we get 760, 314, 972. 1336, 1548, 1947, and 1019, 561. Okay, so we need to know the summation of this, the total. This sign means total. Total of x times f of x, which gives us 8530. Okay, so after we have recorded the information, now we plug into our formula. F of x is 8,530 over 50. Okay, as you can see, now our mean length for our carrots is 170.6 millimeters. As I've said, we have obtained this data from a carrot farm. Okay, so that is all about mean. Now we move, this is a good data, group B data. Okay, and this table is called the frequency table or distribution. As you can see, as I said before, we can display that using a frequency distribution table. Okay? So we have obtained our mean, our average length, which is 1. Now we want to understand the middlemost number for our data. But this one is a grouped data. So before we proceed, we need to create class boundaries. How do we calculate class boundaries? How do we get a class boundary? You take the upper second of the preceding class, minus a lower second of the preceding class, minus the upper second of the first class component. So 155 minus 154, which is equal to 1, and you divide it by 2. So you get 0.5. What you do now, you subtract 0.5 to the lower class interval, and you add 0.5 to the higher class interval. So when you subtract here, you get 159.5 and 154.5. You get 154.5 minus 159.5. You get 159.5. 164.5, 164.5, 169.5, 169.5, 174.5, 174.5 over 179.5, and 179.5 184.5, 184.5, 189.5. Don't mind about my handwriting. What you need to know is to get the concept on how to do the following. So that is all about the class boundary. The reason I want to break the class boundary is you don't want to miss that, as you can see. Here we jumped some information. Here now the data is very clear. So we had our mode formula. We had our mode formula. So now we go and plug in the information. Can we go? Okay. We go back. Our median formula. See, L over 2 plus over 2 minus C over F and H. Okay, this was our formula. Whereby L is the lower class boundary of the median class. Now the first thing that we are supposed to do is to look for the median class, the middlemost class. Our data has the following number: 1, 2, 3, 4, 5, 6, 7, 8. Whereas the middle we have 8 numbers. The middle is between 4 and 5. So 8 plus 9 is equal to, we select the middle now, where our frequency falls in our class boundary. 17 divided by 2. Okay, 8.5. So where is 8.54? 8.54 here. Okay. Okay. This is our lower class boundary. 169.5. We're not plugging in the information. Lower class boundary of the median class. Plus frequency, total number of frequency, which is 50, which is divided by 2 here, minus 21 is a cumulative frequency below preceding the median class. So you add these ones, 8, 6, 5, you get 21. Okay, divide the median class itself, the median class here, the median class itself, which is 9, the median frequency of the median class is 8. Frequency of the median class is 9 times H. H is the width. So if you minus this one, you get 5. When you do the calculations, y product should give you 171.7 millimeter. Okay? This is the median. Now we go to our last one, which is the mode. Okay? The mode formula is given by L plus FM minus 1 minus F over FM plus 1 times the class width. I hope you can see here. So we say that the mode is the frequent number or the highest one. The highest one here is 11. The highest frequency is 11. Okay, so we take the lowest boundary of the model class. Lowest boundary of the model. This one, 174.5 plus 5. Then frequency minus frequency below. So you take 11 minus 11 minus 1. Frequency below 11 minus 1. Then you go here below. What you plug in is the frequency below. Frequency below, as you can see the formula here. 11 minus 9 plus 11 minus 6. Frequency below plus frequency up. In the brackets, in your class widths, this one is this one, equal to 5. We end up with 175 plus 9. Okay? That's how you calculate mean, median, and mode using group data. Okay, so we want to proceed with our slides. Okay, we want to proceed with that was all about measures of central tendency. We want to know the location of our data. Okay, we move on to measures of dispersion. What is the variation? What is the variation of our data? Because we have a data, so the data varies across. So measures of dispersion measures how data is spread out. In other words, it is variability that exists in the data. The variation, as I said before. Here we have range, standard deviation, and variance. So range is simply taking the largest value minus the smallest value. Range is, as you can see, the range formula there. Then we have a standard deviation. Standard deviation is the mean of mean. Now we have the mean, but we want to know the mean of mean. We have the minimum height. Maybe we have the data of Tanzanians. Minimum height maybe 5.5. So we want to know how that mean varies across. So every Tanzanian minimum height is 5.5. So if you take 5 Tanzanians, what is the variation? Maybe one is 5.5 or 6, 5.4. So it moves there across 5.7. If it deviates, it becomes 6. So if the deviation becomes 6, means the standard deviation height has spread out across. If it is below, the data is very closely related. Here are the formulas for the group data. You can still use the table to get standard deviation. And then for group data, for group data, this one. For group data, this is the formula. Then we have the variance. Variance is simply a square root of standard deviation. So it means it's a measure of how far each value of the data set is from the mean. So we have now seen that we have 5.5, 5.6. Now we want to know how far the Tanzanians have the variation. That variation is how far is the variance. Now we go to measures of relationship. We have now seen that the data's variation of the data set. We want to know what is the association, what is the relationship. It is used to quantify relationship between two or more variables. In here we have correlation and regression analysis. These are the most used measures to assess the association between variables. We start with the correlation. Correlation is used to test the relationship between quantitative variables and their categorical variables. You can test between studying hard and passing your exams. How does that correlate? But you should bear in mind that correlation is not causation. What correlates doesn't mean that if your data correlates, it doesn't mean that they cause each other. Okay? So that's why we have these relationships. So correlation coefficient lies between -1 and 1. Zero correlation means there is no relationship between the two. Maybe if you get a zero correlation between studying and passing your exam, means if you study hard, it doesn't guarantee you to pass your exams. But there is a perfect negative and perfect positive. Perfect positive is when you study hard and you pass your exams. But perfect negative is when you study hard and you fail your exam. So that is all about correlation. We also have a regression. Regression determines the relationship between a dependent and an independent variable. How one variable influences another one. Okay? That is all about regression analysis. It can be between one dependent variable and a number of independent variables, or just one dependent variable and one independent variable. When we analyze between one independent variable and one dependent variable, it is called a simple regression. And when we analyze between one dependent variable and a number of independent variables, it is called multiple regression analysis. Okay? Okay, as you can see the definition. The definition of successful relationship between two or more variables. Regression analysis predicts the value of dependent variable based on the known value of the dependent variable, assuming that the average mathematical relationship between two or more variables. In a simple linear regression, there are two variables, x and y. As I said before, when you plot you do a scatter plot, a graph between the y-axis and the x-axis, between age and we want to know that age and income. This is income and age. As you go older, your income increases. You want to know the relationship between y is your dependent variable, income depends on the age. But if you want to add another factor that income depends on also education, it means you have another independent variable that not only age that determines your income, but also your education, your education background, or maybe your inheritance. Okay? That is multiple regression analysis, as you can see. We want to, when you draw a graph, we want to obtain a best possible fitable relationship between these are these dots are the number of observations between, let's say y is income and the x is age. So we try to draw a line whereby we can see the relationship between the two. Okay, so most of the time people confuse between regression and correlation. They think that regression and correlation are the same. But here we can do a comparison in the meaning. First, their meaning is not the same. Whereby correlation determines the relationship between variables, association of two variables. While regression is known as independent, is related to dependent. In correlation, you want to see the relationship between two variables, just a normal relationship, how this variable correlates, how this one. But in the regression analysis, you want to see how independent variable influence the dependent variable numerically. Okay? Another one is the usage. In correlation, you want to present the linear relationship between two variables. How are they plotted in just a line? You just draw a normal line. But in regression, you want to fit the best line, as I said before, estimate one variable on the basis of another. Even for the minimum observation, you want to see how does it fit to another. Dependent and independent variable, here we have no difference. Okay? But here we have both variables are different from the other. Age, gender different. Indicators correlation coefficient in case they say which the two variables move together. Regression in case impact of wind change. Yeah, we want to know the slope of our line. Objective is just to find a numerical value expressing the relationship between the variable. While with regression, we also estimate the value of random variable on the basis of the values of the fixed array. Thank you. That's all about knowledge area 4, which was about processing and analysis of data.